Hi! My name is Marc. Let's learn how to solve and graph an inverse function. Lesson 11. Graphing of inverse function. Learning outcomes. At the end of the lesson, the learner is able to represent an inverse function through its table of values and graph. Find the domain and range of an inverse function, graph inverse function, solve problems involving inverse functions. Lesson outline. Number 1. Graphs of inverse function as reflection about the line y is equal to x. Number 2. Domain and range of a one-to-one function and its inverse. Graphing of inverse functions. Graphing inverse functions. First, we need to ascertain that the given graph corresponds to a one-to-one function by applying the horizontal line test. If it passes the test, the corresponding function is one-to-one. Number 2. Given the graph of a one-to-one function, the graph of its inverse can be obtained by reflecting the graph about the line y is equal to x. Example number 1. Graph y is equal to the inverse of x if the graph of y is equal to f of x, which is 2x plus 1, restricted in the domain x is such that x is greater than or equal to 1.5 but less than or equal to negative 2 is given below. What is the range of the function? What is the domain and range of its inverse? So here we go, guys, to plot the points y is equal to 2x plus 1. So here we now again, guys, to plot the function of the inverse, which is x plus 1 all over 2. So guys, here we go to combine the function and the inverse function of the expression. Okay, what have you observed? I'll give you 30 seconds to think of it, okay? Hi guys, we're going to plot the points of the equation x is equal to y plus 2 and the points of the equation y is equal to x plus 1 all over 2 and have its own horizontal line test. Have you observed that it passes the line for graphing an inverse function? If you notice that, you are correct! Hi guys! The range of the original function can be determined by the inspection of the graph. The range is the f of x is an element of R such that x is greater than or equal to 4 but less than or equal to negative 3. We need to verify using techniques in an earlier lesson that the inverse function is given by the inverse function of x is equal to x plus 1 all over 2. The domain and range of the inverse function can be determined by inspection of the graph. Domain of the inverse function is equal to x is an element of R such that x is greater than or equal to 4 but less than or equal to negative 3. Range of inverse function is equal to y is an element of R such that y is greater than or equal to 1.5 but less than or equal to negative 2. In summary, domain f of x is equal to x is an element of R such that x is greater than or equal to negative 2. The inverse function of x is equal to x is an element of R such that x is greater than or equal to 4 but less than or equal to negative 3. Range R, f of x is equal to y is an element of R such that y is greater than or equal to 4 but less than or equal to
negative 3.
And the inverse is equal to y is an element of R such that y is greater than or equal to 1.5 but less than or equal to negative 2. Hi, what have you observed on the summary? I'll give you 30 seconds to think of it. Observe that the domain of the inverse is the range of the original function, and that the range f of the inverse is the domain of the original function. Example number 2. Find the inverse of f of x is equal to 1 over x using its given graph. Let's now find the inverse of f of x is equal to 1 over x using its given graph. Solution. Applying the horizontal line test, we verify that the function is 1 to 1. Since the graph of f of x is equal to 1 over x is symmetric with respect to the line y is equal to x. Therefore, the inverse of f of x is itself, or f of x is equal to the inverse of f of x. We need to verify that the inverse of f of x is equal to 1 over x using the techniques used in the previous lesson. Okay, guys? Example number 3. Find the inverse of f of x is equal to the cube root of x plus 1 using the given graph. Okay, this is the graph of the equation f of x is equal to the cube root of x plus 1. This is now the graph of the inverse function of x is equal to x cubed plus 1. Solution. Applying the horizontal line test, we confirm that the function is 1 to 1. Reflect the graph of f of x across the line y is equal to x to get the plot of the inverse function. What have you observed when we apply the horizontal line test? I'll give you 20 seconds to think of it. After thinking about what happened to the graph, have you noticed something? If you notice that it is a 1-to-1 function, then you are correct. Hi! The result of the f of x is equal to the cube root of x plus 1 is the graph of y is equal to x cubed minus 1. Therefore, the inverse function of x is equal to the x cubed minus 1. Hi, example number 4. Consider the rational function. F of x is equal to 5x minus 1 all over negative x plus 2. Let's see its graph. Hi! This is the graph of the function f of x is equal to 5x minus 1 all over negative x plus 2. Let's see the curved lines. That's it. Hi, this is the graph of the inverse function of x, which is equal to 2x minus 1 all over 5 plus x. Hi, find the following. A. Find its domain and range. B. Find the equation of its asymptotes. For C, find the graph of its inverse. And for letter D, find the domain and range of its inverse. So you need to find the 4 letters. Okay? Solutions. A. From our lesson on rational functions, we get the following results. Domain of f of x is equal to x is an element of R such that x is not equal to 2. The range of f of x is equal to y is an element of R such that y is not equal to negative 5. So as you can see the graph on the right side. Solutions. C. Using techniques from the lesson on rational functions, the equations of the asymptotes are vertical asymptotes x is equal to 2, horizontal asymptotes y is equal to negative 5. Letter C. The inverse can be graphed by taking the reflection of the graph across y is equal to x. Observe that the new asymptotes are the old as asymptotes with the x and y values interchanged. In fact, the asymptotes could also be obtained by reflecting the original asymptotes about the line y is equal to x. Letter D. The domain and range of the function and its inverse are as follows. Domain. F of x is equal to x is an element of R such that x is not equal to 2. The inverse of x is equal to x is an element of R such that x is not equal to negative 5. The range of f of x is equal to y is an element of R such that y is not equal to negative 5. The inverse function of x is equal to y is an element of R such that y is not equal to 2. Okay guys, what have you observed on the domain and range on our given? I'll give you 20 seconds to think of your answer, okay? Okay, guys, we can make the observation that the domain of the inverse is the range of the original function, and the range of the inverse is the domain of the original function. Example number 5. In the previous examples, what will happen if we plot the inverse function of the inverse function? Solution. If we plot the inverse of a function, we reflect that original function about the line y is equal to x. If we plot the inverse of the inverse, we just reflect the graph back about the line y is equal to x and end up with the original function. This result implies that the original function is the inverse of its inverse, or the inverse of an inverse function is the f of x. Solving problems involving inverse functions. Example number 6. You are asking a friend to think a non-negative number. Add 2 to the number, square the number, multiply the result by 3, and divide the result by 2. If the result is 54, what is the original number? Construct an inverse function that will provide the original number if the result is given. Okay, solution. We first construct that we will compute the final number based on the original number. Following the instructions, we come up with this function. So this is the function. Okay, the graph that is on the left is not a one-to-one function because the graph does not satisfy the horizontal line test. However, the instruction indicated that the original number must be non-negative. The domain of the function must thus be restricted to x is greater than or equal to 0 and its graph is shown on the right. Hi, it is the interchange of x and y variables. So this is the solution, guys, for us to solve y in terms of x. So we get the y is equal to the square root of 2x over 3 minus 2. Finally, we evaluate the inverse function at x is equal to 54 to determine the original number. So as we evaluate the x is equal to 54, the original number is 4. Example number 7. Engineers have determined the maximum force in T tons that a particular bridge can carry is related to the distance d in meters between its supports by the following function. T of d is equal to the quantity of 12.5 over d raised to 3. How far should the supports be in the bridge is to support 6.5 tons. Construct an inverse function to determine the result. To lessen confusion in this case, let us not interchange d and t as they denote specific values. So we get the cube root of t is equal to 12.5 over d. And the inverse function is d of t is equal to 12.5 over square root of t. Okay, evaluate the function at t is equal to 6.5 is 2d multiplied to 6.5. So 12.5 over 5 over the cube root of 6.5 is equal to 6.70. The supports should be placed at most 6.70 meters apart. Solved examples 1. If f of x is equal to the square root of 4 minus x is related on the domain x is an element of R such that x is greater than 3 but less than or equal to negative 5. What is the domain of its inverse? Solution. The domain of the inverse of f of x is an element of R such that f of x is greater than or equal to 3 but less than 1. Therefore, the domain of inverse x is an element of R such that f of x is greater than or equal to 3 but less than 1. So number 2. Given the graph of f of x is equal to square root of 4 minus x. So guys, this is the graph of f of x is equal to the square root of 4 minus x. Given the graph of f of x is equal to square root of 4 minus x, solution. The graph of the inverse of x is just the graph's reflection along y is equal to x. So we get this, the red arrow. Number 3. Using algebraic methods, construct the inverse of f of x is equal to the square root of 4 minus x. Is the function you get the same as the sketch of the inverse in the previous number? Solution. To get the inverse function, we first interchange x and y in y is equal to the square root of 4 minus x, so we get x is equal to the square root of 4 minus y. We then isolate y. Okay, so x squared is equal to 4 minus y. We need to transpose x squared and y so that we have come the y is equal to 4 minus x squared. So, we get the inverse function of x is equal to 4 minus x squared. However, the graph of that will result in a parabola opening downwards, while the sketch we have in number 2 was just half of that parabola. This occurs because the function must be 1-to-1 to have an inverse. Exercises. Number 1. Find the domain and range of the inverse of f of x is equal to x squared minus 6x plus 1 with the domain restriction x is an element of R such that x is greater than 3 but less than 0. Number 2. Give the vertical and horizontal asymptotes of f of x is equal to x plus 3 all over x plus 1. Give the vertical and horizontal asymptotes of its inverse. Number 3. At what point will the graph of f of x is equal to 2x minus 5 and its inverse intersect? The formula for converting Celsius to Fahrenheit is given as F is equal to 9 over 5 C plus 32, where C is the temperature in Celsius and F is the temperature in Fahrenheit. Find the formula for converting Fahrenheit to Celsius. If the temperature in a thermometer reads 101.3 degrees Fahrenheit, what is that in degrees Celsius? Hi, I'm back! I hope you learned so much things in this video. Thanks for watching, guys! Bye-bye!